Neural network in 5 minutes. This is a biological neuron. The octopus-like thing is receiving signals and branching thingy at the end is to transmit signals. And this is an artificial neuron. TikTok uses these to recommend you dancing cat girls. Here are the timestamps and let's get started. Let's break down a single neuron or node and how it gets its output. Y stands for the output of the neuron. M stands for the strength of the correlation of a neuron on the layer before it to itself, or the more technical term, weight. It could also be the weight of the input on a neuron. X stands for the output of the neuron on the layer before it, or it can be an input. C stands for the bias of the neuron. To get the output of a given neuron, or the Y, you need to multiply all the outputs of the neuron on the layer before it with their respective weights to the neuron, or multiply all the inputs with their respective weight to the neuron. As you can see, there is mx in this equation, only one, so there's only one weight or only one input slash output of the neuron on the layer before it. And C, bias, there's only one bias per neuron. I'm sure some of you may still be confused, and I was too, and I believe the best way to learn is through examples. So let's make a very small and tiny neural network about Leonardo DiCaprio's dating life. So what will be the inputs for this shameful neural network? I'm pretty sure you are aware that he has some specific tastes regarding his partner's age. And let's add looks too, standard looks. So here, Y represents how much Leonardo DiCaprio likes the person on a range of negative infinity to positive infinity. As you can see, the weight for the age input has been set to 10, so times 10, because he holds a high regard for age, so it has a stronger correlation. So since we have the inputs, the weights, the bias, 0, we can start calculating. So let's first do a test run of age 100 and looks 10. As you can see, the result is a score of 1010, which is definitely not correct, because a person of age 100 shouldn't have that high of a score, even if it's a 10 out of 10. So we can visualize this on a graph. Let's just type in our equation, 10x. As you can see, the higher x goes, the higher y goes. Y is the score, so that's not good. So how do you make it so that the higher x is, the lower y is? Adding a negative sign. So we calculate again, and we get negative 9,990. Sounds about right. Let's now plug some new values in about age 21 and looks 10. Using our new weights, we get output of negative 200, which definitely isn't right, because that is well within his age range and a perfect 10 out of 10. Typing in our equation, and we can see that it only gives a positive score if the x is negative, which I don't think there's negative ages. This is where the bias can finally come into play. As you can see, the top limit is 25. So now let's add a bias of 25 or 250 to counteract the weight of negative 10, and after calculations we can get an answer of 50, which is pretty fair. To recap, if you want to calculate the y or the output, you need to multiply all the weights with the respective output of the neuron layer before it, or the input. In this case, there was 2 inputs into one neuron, so there was 2 weights and 2 inputs, x and w. Only one bias per neuron. You may be wondering, if a single neuron is that simple, how can some neural networks detect a cat from dogs? This video that I'm going to show you, that is not animated by me by any means, I wish I could, shows the sheer insurmountable size that a large neural network can be. Towards the end, even drawing them on a computer can lag. Which is not even factoring in that if you actually had to calculate all of the weights times all of the outputs, the inputs plus the bias. Here is the book that heavily inspired me to make this video, and yeah, check it out if you want to learn more. Please comment down if you want me to make another video deeper into neural networks with forward and backward propagation, how neural network actually change after giving the wrong answer, the loss and cost function, learning rate, activation functions, or putting it into Python code. Hope you had fun watching, and I hope you learned something useful. A sub would be very much appreciated. Have a great one.